All right, so I guess we will begin, and those who will join, will be admitted. So, as you know, well, first of all, my name is Sasha, and I'm gonna host this webinar. As you all know, we have introduced Visual NAND Reconstructor 8.0 this on the past week. And it has quite a few the very new features that we have been developing for a while. Took a while us to make it. Now I will begin from really simple things. As always, we have added some of the pinouts. We have not only added, but we have also revised several memory chip configurations. They have now, if you noticed, they have now couple more bytes to the identifier. Yeah, so we have added now like couple more bytes to the identifier because as you can see, some of the chips they have very tiny difference in the very last bytes of the ID, and this difference actually makes quite a bit of difference because some block size difference might be applied to different even if there's 1 bit or 1 byte of difference in the identifier of the memory. So yeah, it's a plenty of chips we have revised. We have added several new XOR keys, obviously. Those are some from the tablets as well as pretty much all kind of devices, including micro SD, SD, and other stuff. Several new BCH ports we have also developed and added into the latest update. All the usual stuff. Several pinouts from our users. Thank you very much, by the way, for sharing it. So one of another addition was several new protocols. So we made our reader ready for the newest memory chips, for the newest protocols basically that are utilized in some of the latest 3D NAND memories specifically. I'm talking about chips with a capacity which is higher than 64, 128 gigabytes and above. Some older protocol for older chips also got supported. It's eDNAND memory chips. Those are devices that respond with a strange ID. Some of you have surely seen that, which is like 50/50 and something. Now, configuration for those chips are very specific. If you got the chip, drop request to our support. We'll basically try to help you because there is no simple way to distinguish between configurations for this particular devices. They have built-in ECC engine, and it's not like classic normal raw NAND memory. It has built-in controller, so it's a little bit different. And of course, one of the biggest, I would say, fundamental probably addition or change was new block manager. The new element which we call block manager. Hope it makes sense. The name makes sense. Block manager. That's basically the tool that is the last step of the whole process of data recovery, and that's the tool that gives you the possibility to manipulate and manage the blocks, or to be able to perform the last step of the data translation or data conversion, which is a block translation or block management or block rearrangement, whatever you call it, which allows you to convert the raw process data with mixed addressing into the proper logical image sequence. And that took us quite a while. It's kind of Well, obviously it's a very similar, or you can tell the same idea. Of course, we have to move blocks from physical space to the logical place. That's the basic concept of this element. But what we did is we have basically coded this one from zero, from scratch, uh, and completely changed elements of the interface, made it much more convenient to use, yet it's slightly different than what you used to work with. So you'll definitely need a bit of time to get adjusted. And of course, we have added some of the very interesting features that allows you to statistically analyze. This is one of the new things in Block Manager, the feature that allows you to statistically analyze data. And this is our very first step towards this, sort of comprehensive analysis of the blocks with data. For now, we can distinguish between data blocks, and you can also distinguish between data blocks, between empty blocks, some sort of garbage blocks in NAND memory, and also some unknown blocks which we cannot identify properly. So surely this is what allows you to speed up the analysis process, in several times. And of course, there's also new interface for user interface for the more interactive or more dynamic approach to to the operations, basically. So because essentially the block table is a table, right? So it has to be treated as table, and in our markers table that we used before, it was maybe slightly inconvenient for many users, maybe for some, and so we have changed that as well. And without further ado, let me show you how that works in the software, in the Visual NAND Reconstructor. So yeah, we have here very typical classic case. I would guess that was silicon motion controller, a simple one. And we have here normal steps as usual: physical image, ECC. There's no bit columns here and all other complicated stuff, just to simplify it. We're going to focus today basically on this particular element because that's where we spend most of our time in this update, and hopefully you can extract a lot of useful features from it. So we have ECC here, we have XOR, we have pair, and so on, and we have here block translation, which is located in here in the marks table. And by double click, you can open it up, and you can see here I guess you are familiar with the interface. Most of you already use tool, or at least seen how to use it. And this is basically how it looks. All those markers, edit features, the filtering features. If you want to filter something, you have to go to the menu, choose it from the menu, and basically do your filtering. Basically, you have sorter. In order to sort something, you have this block sorter feature, where you can manipulate with your sorting, but normally people just do it by default. And yeah, so we have all features here for block management, but they're not really convenient. And what we did with the block manager, we actually try to combine multiple elements into one, first of all. So this is how it works. You can find it in a dump operation. I'm not going to delete marks table. We will just compare this with that, and we will see the difference. So it works in a very similar way, in a very similar manner, but the difference is you don't have to connect anything else. So the block manager element, and this is there was kind of awkward thing for many of our users, like, why do we have to connect the pair, like the last conversion step to the logical image and the marks table, and this is how it gets connected. And we have replaced that. Now you just need to connect to add one element, which is block manager, and it includes, it's all in one element basically. It includes marks table, it includes the logical image element, and so this is exactly where you would open the file system viewer on. So you don't need to connect logical image, you don't need to connect anything else. You only connect block manager, and that's your last step in the analysis. So this will be the last step of your, well, hopefully last step of your analysis. Of course, you can also connect the like offsets and other elements. You can basically work with it as with a normal dump container. So that's how it works. So here we need to, of course, set our parameters. You can see here we have the data area. If you want, for instance, to extract the pages or blocks, you can change it to the page, and then it will keep SA, it'll keep the ECC, it'll keep everything. But by default is data, because usually we connect logical image, so we want it to be last element or last step of our operations. And so it will extract automatically only data areas from every page, basically. So here, there's no any settings in the panel compared to the marks table, which was full of settings over there. So you would have to adjust settings on the panel here, on the right panel, or the sidebar. And then you would need to open the table here, and then you would need to adjust settings inside the element itself, which would make it inconvenient. Sometimes people want to have a look at, okay, so where was my LBN, where was my header? And that was a kind of inconvenient because people had to go back to the workspace and have a look there and then go back to the marks table. So in block manager, we completely got rid of it. We put everything together inside the element itself, and it has very minimalistic settings here, as you can see, which is basically just the data area. And everything else you want, you can adjust inside itself. So open it. So here, that's the main window. That's the main interface, basically, of the block manager. It's empty now because we have to obviously adjust some of the settings. You can certainly see some of the familiar, pieces of interface, but there are some which are completely new for you, I guess. So let's begin with the very first thing. By the way, this is our very first version of the interface. I believe we will slightly change it. I think we will probably patch software, I hope within this year, maybe the beginning of the next year, but sooner or later, hope the better. And the interface will slightly change, but the basic concept will remain the same. So here you have on the left side, you have block list, which is your classic, kind of almost classic view of the marks table with some differences. You can enable, disable these features, but then it will mess up with the screen a little bit, so I'm not going to do it right now. But yeah, you can basically enable and disable the features here. Well, how to input parameters? That's fairly simple. Usually, if you have your LBN, your headers preset somewhere else in the marks in the physical image, for example, they'll be automatically copied into marks table fields, and it'll be the same in the block manager. You'll see in another case, they will be automatically moved here. But let me just show you how you can add, because you will need to sometimes, how to actually add parameters manually here. So at the right panel here, by the way, we also take the feedbacks from users, and we will well, I mean, we will adjust like the interface from this current version. And if you have any suggestions or some recommendations, let's say how to adjust it, send us to our support team, and we will surely consider it and improve it. So here, in order to add LBN now, we just copy it from the old marks table. Let me just show you how to operate with it. So here we have it. Well, that's the parent structure. You can basically add structure on the level of bunks, which is very rare. Most of the time we add structures into the block, right? So because we want to read the data by blocks into the table. So here where we adjust or add all these structures into the parent structure, which is the block structure usually. So LBN, it already exists. We just need to set parameters. If they are not here already, just click on the edit. They should be there by default as you add them to dump. But anyways, let me show you how to do it by hand. So here it is. One of the interesting things which we added here, which also some users requested us, is you can actually add custom fields here. Many people love to add in the marks table. We had only a couple of test positions here, and we got a little bit of complaints like, so it's not enough. I want more of the fields, because some people want to add offset of 510, 511, which is basically the signature of MBR or GPT or boot sectors of the file system, of the metadata. And some people said we need more, so we did add more of it. You can add any, you can add your custom structure. Basically, you can say, well, metadata. You can type whatever here, and you can set byte positions. This byte position within block, because the parent structure here is block. So byte positions, well, let's put 510, 511, for instance, which is familiar for most of you. Add, and here you can see the table has dynamically expanded to the field that you have added. You can obviously move it somewhere else as you want. So now we have some parameters predefined here, and we can finally build the table. And this is a new feature: calculate statistic to determine block type. Yes. So this is a new feature which basically allows you to analyze, to determine, and to analyze the type of block, whatever type it is: data block, empty block. We also split empty blocks into FF blocks as well as zero blocks. So there could be two types of empty blocks. Yeah, that takes a while. So let me just stop it here. And I think the next case is I have pre-built the table, so you don't have to wait for it. That's a buffer. Yeah, so part of blocks has been identified already. Now let's just see how to operate within the table. And so here you have some obviously classic parameters such as LBN, such as header. And for those of you who are familiar with the art, You know, you need to invert data here because it's like too high values here. And we have all the features for manipulation with bytes and bits here. And also we keep all the commands that you add. Now you have the convenient history of commands which we applied. Yeah, so here's the classic basically feature marks edit, which we had in the marks table as well. So if you want to modify to invert the spur, you can easily do that. Just don't swap, doesn't invert your metadata because you won't be able to see 55A then. So here it is. So we have inverted SA or structures from the SA. And now we can see more readable, you know, more familiar block table or block numbers of the block data. And as you can see, you have LBN, you have header, you have address, and physical block number, which is basically address. And you have here the block type, and you have your field with your metadata. So this is very simple. Metadata is your simple custom field, which you can add here. That's just the bytes from the dump. However, the block type that's a complex function that basically the function that has a lot going on in the background. So we analyzed every single block statistically to figure out what kind of content it has. And this feature works on XORed, on the devices with the XORed data. It doesn't work so well on devices where data is not XORed, because sometimes it's just, hard to determine if your block full of zeros is actually data or that's empty block. So the feature works perfectly and very precisely, by the way. So if I click on some of those to check empty, and you can see in the middle the bitmap that's really empty block. So those question marks are basically unknown blocks, the blocks which we cannot identify properly, which are, sort of unknown type. Could be anything, but not data. And you can trust the function, well, probably 99%. It's quite reliable. It's based on quite complex mathematical, statistical analysis of the data and several conditions that we have like pre-built into the software. So you can more or less rely on it, but you can still check it yourself if the algorithm worked properly. So, you can see unknown blocks, they're really strange. There's some strange content inside. And here we have data blocks and empty FF blocks. There might be also empty zero blocks, which are normally bad blocks. So there are multiple types now. That's a data, which is main type, of course, which you are looking for. Empty blocks, unknown blocks, and some other rare types that you will see in the other cases I'm going to show you here. And well, that's about block type. And obviously, this feature is very useful when you analyze and you have multiple blocks. You have like several blocks with the same LBN. You have 2 blocks or 3 blocks, and you have, you want to choose from. And this will also help you to make your decision faster and better and more sort of comprehensive, in order to select the proper block with the data in order to rebuild logical image, rather than just hitting, first or last block completely randomly, let's say. We have here, okay, so now let's get to the tools that we have inside the markers table. So previously, inside block manager, sorry. So previously in the markers table, you had 2 options basically, two main options. You had a option to filter blocks by any parameter you want, and then you had the feature to sort blocks, right? You want to sort them into proper order. So it was only filtering, and it was then sorting. In the concept of block manager, we actually have three features now, three functions or three operations, you can say. It is filtering, which is classic, not much different from previous one. It is sorting, which is different from what we had. And it is now the new feature, which is grouping. You can group data. You can group data by blocks. You can group data by LBN. You can group blocks by type. You can group them by basically by anything you want, which is sometimes very helpful just to see, okay, like how many duplicates of this particular block I have, and how many duplicates of one particular LBN you have, for example. And the usage is quite universal. It may not only be applied to the block management, but maybe you analyze some data, maybe you analyze something else, and the instrument is the tool. This tool is quite universal. It is kind of different to use, so you'll need a little bit of time certainly to get used to it. But I hope it will be easy and a fluid transition from the marks table to block manager. And so let's have a look how to operate in here. So the table is interactive, as you can see. You've got a filters right there, so you can filter now straight, from the menu, basically from the tab. And when you hover over LBN or over header, you can actually see the offsets. The offsets that have been used. That's also one of the requests our people were asking, like, please put somewhere, the information about my LBN, my header, where they are, where I took them from, because I've got to go back to workspace just to see where they are. So now it is more flexible. So now let's see how to actually operate with these tools. So if you want to filter something, for example, you want to filter block, you want to filter by header, right? So you can type here. So for silicon motion, for instance, we want to filter from header 20 to header, I think 3F. So, all right. So here you see now we have filtered data by the header, and just as a hint for you, it is highlighted now that the filter is applied actually. And in command, you can also see the whole sequence of commands that have been applied, which makes it more easy now to sort of go back and figure out what was done. Now, once you filtered that, you want to certainly sort it all. And as for sorting, we have slightly changed concept here. It is sort of like sticky sorting. So every time you click somewhere, for example, you want to sort it by flag used, unused, right? So you click on the used. It has three states: ascending order, descending order, and go back to the default and no sorting at all, basically. So now there's no any sorting here. And now we sorted it as we needed, by flag used to the top and unused to the bottom, right there. And now it is a sticky field, so it is kind of like sticky sorting. It will, when you hit another field here, so as you already noticed, you can sort data right from the table, so it's kind of more interactive way. And when you click here, it'll take into account your previous sorting. So basically, as you can see, so you have sorted it first by flag use, and then we sorted it by LBM. Because we didn't wait to the end, there is no type here, but that will be actually data block, of course. So we didn't analyze all of them. You can see the metadata, which is 558, which is convenient. And yeah, that's fairly simple case, and this is how the sorting feature works. Filtering and sorting works here. Of course, you can also check the blockchain. So we also slightly changed that because you want to find the duplicates, right? You want to be able to analyze duplicates, check how many of them, which blocks have them, and so on. And so with this check blockchain feature, you can easily do that. There's not so many duplicates here. There are some gaps though, but that's the end of them, so we don't care for now. For instance, if you want to use group feature, this is not the best case to show, but on the next case, I'm going to show you how to use it. But you can also group data by, for instance, by type, which is very convenient. By the way, you can just look at the data blocks specifically and ignore the rest. So. All right, let me show you how to build image now, and then I'll show you some other features. So once you have done your simple, in this case, analysis of the block sequence, you can build logical image. So here's two features we have. The first one is build table from scratch, or rebuild table if you hit a second time. It's just to read markers, sort of like the build table and read it from the dump. And then we have, like, once you have done all your analysis, the next feature here is you want to basically apply all these operations you have done. So you want to build logical image from that. And here's the button here, build logical. As I told before, the interface will be changed slightly here. But that's our first version of VNR 8. So if you want to build logical image, you just click on the build logical image, and it's actually built. And there's nothing really going on, rather than there was a warning sign here. It's gone now, so the element is all set. And as you can see, that's basically the last step, or that's your last result. Same as this one. So basically, the block manager contains inside those two plus some other features. And now the big question is, okay, where to add logical image? Where to open up logical image? Of course, right on the block manager element, because it is now not only the list of addresses like Mark's table was, it is also the container of the dump itself. So I can open file system viewer on that. On that very element, on the block manager element here. And we would have same result as if it was the logical image. And if you can also obviously work with it. For instance, you can save the dump. Well, this dump has a lot of bit errors. ECC wasn't even on; it wasn't corrected because it's not about ECC here. So this you can also save as image, or you can export it as from the file system viewer. You can export it from here. I mean, all features available like on logical image basically. So nothing really new from that point of view. If you need to insert blocks, for instance, let's go to the very end of sequence. We don't have to really need to do it here, but let me just show you how it works. let's say we have a gap here between this and that blocks. I mean, that's the last block, most likely empty or garbage, but yeah, technically, let's just try to fill up the gap. There is a huge one between 2EF and the 3C5 blocks, but it doesn't matter. So here's the insert all missing blocks button, and that's now filled with basically dummy blocks in order to compensate offsets in logical image in case you need it. Well, a couple of more advanced features, but I think we will talk about it in the article when we make one. I hope within a couple of weeks as we slightly adjust interface. You can also do complex kind of complex checking here of the LDM. If every byte changes specifically, if every byte has specific range of values, you can basically adjust it here a very convenient way now in the in the settings of the block manager. You also have, because it's not really very important feature, not very much used by users, and you don't really have to use it like in every case, the page manager, which will show you the pages of every block. We moved it to the right side. You can also basically disable it if you don't need it. You can also disable settings if you don't need them. The interface state, well, we will even improve a little bit more the interface, so it will be a bit more flexible. I think it will be patched in the nearest coming weeks, hope before Christmas, before the 24th of December, 24th of December. So yeah, these are just the basic case, the basic review of the features that we have added. Now let me open a maybe more interesting case where we can test all the power of the feature. All right, I hope you can see the next case. Okay, so that was micro SD card. Sorry, micro SD or monolithic SD card. I don't know exactly from the SanDisk. Solution is quite classic actually. I think it's in solution database of ours. There was ECC corrected, XOR, double pair, the block rotation feature. So that's quite complicated. Well, let's say quite a sequence here. Not very complicated because we have solution for it, but quite a sequence, yeah. So let's open the max table, the old one, and you'll see that's a typical solution for the SanDisk well, one of typical solutions, let's say, of the SanDisk, microSD, and mono SD cards. The blocks have headers 30, B0, and some others. Data must be assembled by blocks with the help of rotation. So there are some page rotations within the blocks. They can be easily handled by the particular element here. So we have special functions for the rotation. So it was taken care of in the previous steps. So here we have seemingly simple table. It was already pre-filtered. And if you can notice here, there are some duplicates, some duplicated blocks. Selection was based kind of on guessing process. You just look at the previous blocks, what they had, what kind of data they had, and then you look at that one, and it's full of data, and this one is empty and almost empty. And yeah, you can base your decision based on the content of data. So now let's have a look at how would we do. Well, let's first build logical image. So yeah, there was, I think, test data sets here. And so I have this block manager connected to the last step of transformation. Basically, if you saved case before, as I did now, and you pre-calculated statistics of data, statistics of blocks, it'll ask you, do you want to open, because instead of running it again and waiting like 5 minutes or 10 minutes, depending on the dump size, the bigger the dump size you have, the longer the process of statistic calculation will take. So you better to use it on the SSD drive, of course, and powerful processors such as Core i7, for instance, Intel or similar of AMD. But yeah, if you did it before, it'll ask you, do you want to load it? Of course, yes, because you don't want to waste time now. And you can already see I had predefined LBN here and header. There were some of the transformations, some of the filterings done, some of the sorting is done already. You can see that in here. You can, by the way, remove the step of history. Right now, it's not actually removing the actions that it's done. But let me clean it all. So I'm just going to hit set use all and remove all kind of filters and sortings here. Yeah, actually, as you can see, it keeps, I forgot about it. It keeps all operations that we didn't delete. So that's actually a quite useful feature usually. Because you don't want to lose steps you have basically already done. So now let me just sort it by LBN and show you how it looked at the beginning. Or maybe let's just keep it as it is. So now you can clearly see the data is completely mixed here. There is no any sequence in the LBN, which we're looking for. And there's a mess in the dump. But you can already kind of navigate in this mess because you can already see the data types, the block types. It shows you the block types, whether it's data or empty, and it makes the whole analysis much more convenient, obviously. We can add, if you like, MBR or just 5555 AA offset here, as many people love to add. We'll need to rebuild it. Yeah, and you see this all operations. We will actually, yeah, we didn't add the feature yet to remove them all. We'll certainly do that. Okay, so now we got it in the there you go, in the original shape as it looks in the very dump. So yeah, you see the row table now, and at the beginning of dump we have some unknown blocks as usual. This is a very typical situation with almost every single case. And you can see we can distinguish clearly between the really empty blocks or blocks with I'm not sure if there are some blocks with zeros here, but we can group it by type, and it will show us how many of each block we have. Okay, we don't have empty zero blocks here, so we only have FFs. But anyways, we can clearly distinguish between the real empty blocks and the data blocks. So now at the very beginning of analysis, you can basically filter everything by data, by type of block, by data block basically, because you don't want to analyze empty blocks. You don't want to analyze some complete garbage blocks, let's say. Right now you have to type data here, but we will also adjust it, so you will do it from the context menu, I think, like from the right click here. So now we see we filtered data. We filtered at the very first step. We got rid of garbage blocks, the blocks which we don't need. We don't need empty blocks. We don't need unknown garbage blocks. So these are unknown blocks because we don't really always know what it is. It's something, if you're interested in having a look at them, you can do it at the end of analysis. Just go through them, and maybe there will be blocks with a couple of pages, with 1 or 2 or 3 pages with the real user data. So if you're doing forensics investigation especially, you might actually want to go to these blocks and have a look at them. And this feature with grouping can conveniently, actually, it may help you to conveniently do so, because once you deal with the data blocks, you don't need them. So you can analyze them. There's unknown blocks. You can go through them one by one. Some of them will actually have legit LBNs, so you might want to have a look at them. But very few of them will have the data. Okay, so this one, as you can see, actually holds the data. So this is why it actually makes sense to sometimes check them, especially if they have legit LBN numbers. So as I said, precision of the algorithm is, well, of course it is not really 100%, right? It is probably 99%. Probably, I would say, well, it's actually like 99.99, I guess, because you see, out of 2,000 blocks, or almost 2,000 blocks, we only got probably like one or a couple of false positives. So this is not partially full data block. So we probably got a couple of false positives. Actually, this happens because it's not really complete block. So there's a little bit here of FF. So this is like a block which is filled on 2/3, and that's not the block that used in usually in the, well, it might be used actually in translation, but you will have to check your block sequence. If in the sequence this block is missing, then you would want to bring it actually back, and you can easily do so. Well, now what we did was we removed blocks. We only kept blocks with data. Now we want to sort it. Sort by use flag, and then sort by LBN. Sort by LBN. And you can see the proper, well, more or less proper sequence of the data blocks. Well, we can check the sequence, and you can spot here a couple of places where the blocks are actually duplicated by LBM. So what you can do is, oops, for the more convenient, especially if you have many many duplicated blocks, you can group it. You can actually group it by LBM, and you can clearly see how many of duplicates you have for every single block. So here we got a couple of blocks with 1B, couple of 1C blocks. We have a feature here. You can do like select first in group or last in group to quickly and automatically like get rid of one of the blocks. But here's the problem here in this particular case. In many cases, it's much easier. But here in the SanDisk, you've got both blocks and they both contain data. So these are data blocks, which is one of the main concepts of our block manager. So we'll show you what kind of block it is. And that's, not always a good idea to just get rid of random block, especially if you're looking for particular data. So you might want to look at them. And in here, you cannot really choose, one first in group or last in group, because here the first block has data, and in this one the last block has data. So it is not as easy as just to hit it all automatically and get it properly filtered. So the good thing is usually there are not so many of such blocks in the dump. You can clearly see later on we don't have many duplicates, but it's like probably 10 to 15 here. You certainly want to keep the block with most of data in it. Yeah, and then you can remove grouping. It will not affect anything, basically. You don't have to use grouping, let's say, but it's just convenient way of doing many different things. Like when you precisely analyze dump, just to rebuild the sequence, you can group it. Or if you're doing forensics and you're looking for some small piece of data, fragments or metadata file system, for example, that could be a very useful feature just to go through multiple copies of block. And have them isolated and divided by LBM, rather than just looking at the plain table, which is, might be eye blurring. So if you need to fix on some particular portions of data, you might want to group it. And yeah, once you're done filtering, I haven't done the whole filtering here, but anyways, you can build logical image, check your result, and if you don't like it, you can, of course, it will not be ideal here because I haven't finished. And then you can get back here, do the rest of operations, and then rebuild it again and check the data sort of like in real time, pretty much as you can do with Mark's table, by the way. But yeah, all the features, all the settings which you need for work, they are now in one window. So that's one window option. Yep. So yeah, that's the basic concept of the block manager element that we have added into this newest Visual NAND Reconstructor. And let me show you one more case, which is very interesting in my opinion, because this is where I myself several years ago spent probably a couple of hours just digging through the data, digging through the dump, and trying to figure out, is there any data or not really? And now you can do the same thing within probably like 15 or 20 seconds, and you get all data extracted. Yeah, let me reopen another case, and I'll. So here we have another case, and if you open the dump digital image here, it looks really interesting. Like mostly it's empty, which is FF, because for flash memory, empty means to have FFs, right? That's initial condition of the erased flash memory, FFs. And then there's a bunch of those blocks with something, with some kind of garbage. We have no idea, honestly, what it is. It is just probably like because this chip has two planes or two physical memory, memory cell arrays on the wafer of the memory. And so probably just one plane was used and another one not. So basically controller only utilized the even blocks of memory, like 0, 2, 4, and it hadn't used probably the odd blocks. And so they were filled by some sort of complete noise, garbage, whatever you call it. And it was really hard to navigate through this garbage because, like, even if it built mark stable, it would look like there would be numbers. Well, most of it would be, of course, zeros and FF, but there would be some of the blocks with, legitimate headers and LBN numbers such as 88, some 90s, 90, 98, and so on. And moreover, the assay spare area was inverted here. So if you look at the data blocks, at the spare area of data blocks, you will not see 0, 0, 0, 1, but you will see FFFF, FFFE, which makes, logic of normal human being kind of flipped. So it makes really tough to distinguish between, the real data and then the garbage data or empty blocks. Because to me, LBN FFFF means just, empty block. But it's not really, because we have this header. But then noisy blocks, they also had header like 3, 2, blah, 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 and so on. So that was really, really very inconvenient to do it through mark stable. And when I got this case, I did spend plenty of time just trying to figure out, XOR, ECC, and other stuff, because you need data blocks which you want to use to find ECC, to find XOR, and everything basically. So we had to first like build mark stable, pull out, find those blocks, pull out those blocks, and then do processing. But right now, with the help of Black Manager, even with the first version of our Black Manager, you can do it within like really, really fast. Let me just show it to you. So I have it connected here. So now it has a build table and ask me if I want to load statistic file, which, by the way, when you read the memory chip through the reader of the Visual NAND Reconstructor reader, we automatically in the background we generate statistical file of the physical image for every single dump you have. It's a PSF file, PSF, I think PSF or PFS, PSF file. Yeah, it's a statistical file. And so you need that to, if you have it, then it'll work very fast. If you don't have it, it'll ask you to rebuild it again if you don't have it stored before, if you haven't saved before. But now I have it here. So yeah, well, as you can see, this is how the whole dump would look like if I just read the memory, well, after all those conversions. It's just all empty, and this sort of like unknown blocks. These are, by the way, unxored already. So this is why you see that this kind of data, which is not technically data, it's just XOR applied to this garbage, basically. So you see a combination of garbage and XOR key, which is not data. And we can distinguish between that. We can understand that, yeah, it is not a real data because it looks fishy. So it is the garbage. And if you want to sort of estimate the scale of how many blocks empty, how many blocks data, how many blocks garbage, well, you can do quick grouping by the block type, and then you'll find some of the MLC blocks, SLC actually. Well, this is technically the false positive because that's really unknown block or a complete garbage block. And among those, you will see some blocks with it might be firmware or it might be data chunks stored in SLC memory. We will also handle SLC in the next version of the block manager, I hope. There are some real bad blocks. Well, they don't look zeros because, again, it's XOR applied to it, so you don't see the original data. And then an interesting thing is the data, among data blocks, there are only 4 of them. So, and this is XORed already, of course. And as you can see, in a whole dump of a couple of thousand blocks, which are not empty, but mostly like used by some, well, thousands of them look like complete garbage. We have been able to identify only 4 blocks, and that's a real amount of data blocks in this case, with data. And so we can filter it by data, hit use, just to sort it by data blocks, and then here we go. You don't need to, well, yeah, you actually need to also filter it by, sort it by LBN, of course. In case you had more, they will be mixed. And so we got only 4 blocks with the data, and we can rebuild logical image now to check if there's anything basically here. And surprisingly, yes, the device was, well, I wouldn't say full of data, but there were plenty of folders and files. So yeah, that's how much this block type analysis or block statistical analysis can help to basically improve your workflow, save a lot of time, sometimes even to do features you couldn't do before because you didn't know what kind of block was that. And yeah, I hope it will be very useful, and we will certainly improve it. This is our very first version. There might be some bugs, so we'll appreciate if you'll report it, and we'll try to fix it real quick. And we also now slightly improving the interface, so I hope in nearest weeks we will release the patch. There will not be news, I guess, but all of you will get the notification in the software that you can update the current version of Visual NAND Reconstructor, basically patch it. There's no bugs, but we just want to, sort of improve the convenience, let's say, and add several more features here. All right, I hope it was fun. Amarbir, yes, I hope we will do more webinars. You just guys send us some maybe topics for which to the webinars. And for this one, we will certainly do article because I think webinar is good, but some prefer articles. So, all right. Thank you guys for your time. And yeah, I hope it was fun. I see you. Bye-bye. Thank you.